Well, hello there. Welcome to this interactive workshop on 21st century math tools. And you probably have seen a flyer like this, and that's why you're attending. This workshop is aimed at students or teachers or parents of students that are interested in mathematics, either at the high school level or tech school or college. Now, the facts of the matter are anyone who's interested in learning or using math in any STEM subject, or for that matter, any other technical subject, really needs to be fully aware of two revolutionary tools that are now available in this 21st century. One is called Wolfram Alpha, which was introduced in 2009, and the other was called Wolfram Language, which was introduced in 2015. Now, the facts of the matter are these tools revolutionize how you learn math and how you do math, so you need to know about them. Now, one in particular, Wolfram Alpha, is like having an expert mathematician on call 24/7 to solve any kind of a math problem you might have, whether it's algebra or geometry or calculus or whatever. And also, if you can solve the problem manually, if that's possible, then it will also teach you how to do that. And so it becomes really like an expert math tutor. And so the facts of the matter are that's what this interactive workshop is going to explain to you. And so sit back and enjoy, and you'll learn all about it in the next hour or so. Now, I have a set of notes that I'm going to be following as I do this workshop, this interactive workshop with you. And it's about 5 pages long. And I will give you a set of these notes so you don't have to take notes. If you want a set of these notes and you give me your email address, I will send you a PDF copy of them so you don't have to take notes, because there's really a lot to learn here. The first thing I want to talk to you about is the idea that mathematics consists of two things. It consists of concepts and then also tools. They're two different things. Now, the facts of the matter are that if you're going to teach the concepts are actually pretty easy to learn. And if you use what we call spike pedagogy, which means self-pacing, proper content, interactivity, keeping score, and empathy and humor, if you use all those things and you're a good teacher, teaching the concepts is really pretty easy. And once you've done that, once you understand the concepts, though, then you have to have tools to apply these concepts and to solve problems. And it's the tools that what empowers the understanding of the concepts and the use of them in practice. Now, math is really kind of what I call a contact sport, and that means you really learn it by doing it. So you're not going to learn the concepts just by listening to someone talk about them. You're going to have to go out and apply them and use the tools to apply them, and that's what learning math is all about. Now, the facts of the matter are, in order to fully appreciate what the modern technologies do, we need a historical perspective, I believe. And so I'm going to spend probably 15 minutes talking to you about the history of mathematics, both the concepts and the tools, so that you'll have a better understanding of just why this has evolved the way it has and why it is so important today, and how math education is being transformed dramatically by modern technology. Well, if you are a teacher, you will already know what I'm about to tell you, but if you're a student, here's what you're going to be learning. You're going to be learning concepts from a subject called algebra, and you're also going to be learning about geometry, and then trigonometry is sort of an extension of those things, and analytical geometry is an extension, and these are all things that are taught in a typical what is called pre-calculus. And then if you're going to go into science and technology and engineering, STEM subjects, you're going to learn calculus. This is the most important tool you're going to learn then once you go beyond these pre-calculus tools. And after calculus, what's the most important thing in science and engineering are called differential equations. And what you're going to do with these tools is you're going to create something called functions, and you're going to learn how to graph them, and you're going to analyze these functions, because it's these functions you use to create math models. And these math models are what you use then in science and engineering and in all sorts of technical fields. And so you're going to learn this and more. Now, as I said, you're going to first of all learn the concepts of these. And you might think, well, that sounds pretty scary. Actually, it's really quite easy to learn these concepts. The concepts are not difficult. The problem comes with the tools, the manual tools that you are taught today and that we've been using. And when you go to the modern tools, which is what I'm going to be telling you about later in the workshop, all of this becomes much easier. As a matter of fact, today, you can learn these subjects in a small fraction of the time it took you in the traditional way it's taught even today, and certainly the way it was taught historically. And so that's what this workshop is really going to be all about. Well, let's start out and just talk about the history of doing arithmetic calculations, multiplication, division, all those things. The tool that was developed to do this, by the way, the concepts are really pretty easy to learn, but the tool that was developed to do it, and they're very hard to do with just pencil and paper, was something called logarithms, and a slide rule is based on logarithms. And this was developed back in the 17th century. That's the 1600s. And this is a tool then that was used by engineers and scientists to do arithmetic calculations for literally 2 or 3 centuries. In fact, this was the tool that was used right up until the later part of the 20th century, because in 1972, a first electronic calculator, scientific pocket calculator, was developed by a company called Hewlett-Packard. It's called the HP35. And it was an extremely revolutionary thing, because all of a sudden, an arithmetic problem that would take you 20 minutes or 30 minutes with a slide rule could be done in 1 minute with a scientific calculator. It was quite revolutionary. Now, it wasn't inexpensive. It was $395 in 1972, which is over $2,000 in today's dollars. So it was pretty expensive. And Hewlett-Packard thought they'd maybe sell 10,000 of them to professional engineers and scientists, but right away, students that were in engineering schools started buying them, and the first year, instead of selling 10,000, they sold 100,000. Well, then, of course, the price really started coming down quickly, and Texas Instruments got into the game, and they began to develop calculators. And today, when we teach mathematics in one of our training programs, we use the TI-30XA, which is a much, much better calculator than the original one for lots and lots of technical reasons, and it only costs about $10. So today, if you're going to do arithmetic, you're definitely going to use some kind of a calculator. This is the one we use because it's so good. It's just a very excellent calculator, and it's very inexpensive. And we can start teaching students this at a very, very early age. They can begin to use this to do arithmetic and to learn arithmetic. And so this is a wonderful tool that was developed for arithmetic. Now the question is, what about the more advanced subjects that came along? Well, algebra and geometry and trigonometry were developed over the years, and by the mid-1600s, some people began to develop a subject called calculus, and Leibniz is probably the one that I give the most credit to for this, although Isaac Newton also developed it and applied it. But Leibniz's version of calculus is the one that's most commonly used today, and not only did he develop the concepts of calculus, he began to develop the tools to use. Well, then the other mathematicians came along and extended these tools, and probably the most prominent one of these was a guy named Leonhard Euler in the 1700s. And between Leibniz and the Bernoullis and Euler, they developed all of the tools of calculus that are used today, the manual tools and the concepts. And so calculus has been around now for over 2 centuries, and the tools that these guys developed to do it were just phenomenal, and it just really enabled this science to go forward. These are the mathematical concepts and tools behind modern science and technology. But now, unfortunately, these tools that were developed by Euler and his friends, they use pencil and paper and then algorithms, are very difficult to learn and very difficult to apply. And they, unfortunately, are still the tools being used today in our standard math curriculum, and are very difficult to use. Now, I want to give you an analogy so you kind of understand the difference between a concept and a tool. The concept of a hole in a piece of wood is a very easy concept. Anybody can understand what a hole is. The question is, what kind of tool are you going to use to create the hole? Well, back historically, in the early part of the 20th century, you used a manual tool called a brace and bit. And you had a bit down here, and then you had this mechanical thing where you could turn this around and around, and that would make the bit turn around, and you could drill a hole with it. And a brace and bit is what carpenters use. Now, I will tell you, it is very difficult to learn to use a brace and bit. It's also very time-consuming and hard to do. It takes a lot of strength. It takes a lot of agility. You got to be very athletic to do it. Well, of course, what happened was, once motors came along, and little electric motors, they now have electric drills. And so today, if you were going to drill a hole, you'd use an electric motor. And it would be much faster. And also you can drill a lot of holes you can't even do with a abrasive bit. Notice how big this is. Well, there are a lot of places you can't even get with one. So the new modern tool of an electric drill is so much better than the manual tool. Well, that's what's happened in mathematics, particularly in the fields of calculus and differential equations and trigonometry and all that sort of thing, is we now have new modern tools. And that, of course, is what I'm going to be telling you about as this workshop continues. Okay, now let's talk about the modern tools of mathematics. In 1959, a young boy was born in England by the name of Stephen Wolfram, and as he grew up by the early 1970s, about the time that the scientific calculator came out, there was an amazing tool developed at MIT, Massachusetts Institute of Technology, called Maxima. Now, this ran on a much larger computer, of course. This was before the internet day, and so it was not widely available. But somehow, when he was in his early teens, Steve Wolfram got access to Maxima, and he used it to develop, solve problems in physics, and he started publishing physics papers as a teenager that really impressed everybody. And he ended up going to America, and he went to the California Institute of Technology and studied theoretical physics with people like Richard Feynman. That was the best physics school in the country then. And because of this fantastic tool, he was able to do things in theoretical physics. And he got his PhD when he was 20 years old, essentially, in 1980, which is unheard of. PhD in theoretical physics at age 20. Yes, he's a very, very smart guy. He is a genius, I would say, but he had this tool. This was the tool that was the key to it. And I will tell you that he didn't study the manual tools of mathematics. He couldn't have done that. Nobody at that point could do that. He used this wonderful tool called Maxima. Now, once he got his PhD in mathematics, he was given a Genius Award, a MacArthur Award. He had a lot of money, and he decided he wanted to develop a much, much, much stronger tool than the Maxima. And so he went to work, and he developed then a tool called Mathematica, which he introduced to the world in about 1988. Now, at the same time all that was happening, Steve Jobs from Apple had left Apple in 1985 and had set out to develop the next computer. Now, the next computer was a much more powerful computer than the Macintosh that Jobs had developed, and it used all sorts of things. I won't get into the details of it. It's just much more powerful, Unix-based system, and it sold $6,500 when it came out in 1990, more or less, and it would be over 13 grand in today's money. But what happened was they loaded it with Mathematica. And so when the next computer came out, it had Mathematica, and so everybody started using it, all the professionals that could afford it. And so over at CERN in Switzerland, the big nuclear facility, a guy named Tim Berners-Lee used this tool, the next computer and Mathematica, to develop the World Wide Web, which you've all heard of. So that's how powerful this was. And I don't think it could have been done with any of the other computers of its day. And so you had this fantastic thing that was developed called Mathematica. And then in 2009, Wolfram introduced Wolfram Alpha. Now, Wolfram Alpha is something that's what I'll be talking about in the rest of this workshop and explain it to you. And but then I will also tell you that in 2015, he developed something called the Wolfram language. And there's a thing called the Raspberry Pi, which is a little computer that was developed in England and sold it's for educational purposes. And this is the model of it here. This is what it looks like. You can buy one for $35, and this is it. I'll show you a picture of it in a minute. I'll actually demonstrate one physically to you in a little bit. But in 2016, Wolfram bundled Mathematica and Wolfram Alpha and Wolfram language on the Raspberry Pi. And that's just an absolutely phenomenal thing that makes it so usable now. So this is the modern tool that I'm going to be teaching you about. The problem is with the Raspberry Pi, it's pretty challenging to use it for if you're not a technical expert with computers and stuff. And so in 2017, a thing called the supercomputer came out, and this is the Raspberry Pi that's made much usable for any kind of a student or any person without having a lot of technical expertise. And I'll be telling you more about that later on as time goes on. And so that is going to be then what we're going to do in the rest of this workshop is we're going to teach you about Wolfram Alpha. Wolfram Alpha is a website. It's free. It does a lot of things, and that's what I'm getting ready now in the rest of the workshop to teach you.